Question number 9. Water is poured into a tank at constant rate of 500 centimeter cube per second. So that means this one which is given to us is dV over dt, that is the volume with respect to time, right. The depth of the water in the tank t seconds after filling starts is h centimeter. When the depth of the water in tank is h centimeter, the volume V centimeter cubed of water in the tank is given by this formula. Find the rate at which h is increasing. So we are looking for rate of h, that is dH over dt. So dH over dt we are going to find out. That's what we require. So now what we are given, we will start with that. We have dV over dt, which is 500. We have this 500 centimeter cubed, and then dH over dt we are going to find out. Now what we are given? We are given V is equal to 4 over 3 25 plus h power 3 minus 62,500 over 3, right. So now we are going to differentiate to find out dy over dt. So that is going to be this 3 will come, 4 over 3 is here already, then 3 25 plus h power 3 minus 1 it is 2, and minus the derivative of constant is 0. So this 3 and 3 is cancelled. So then we have dV over dH is equal to 4 into 25 plus h squared, right. And now we are given that this h here, find the rate of at which h is increasing and the instant when h is 10. So h is 10 here, we are going to substitute here. When h is 10, then dV over dt, just replace h by 10 squared. So this is 4 into 35 squared, that comes out to be 4,900, right. So this is our dV over dt. dV over dt we got 4,900. So let's say this is equation number what we are given. We were given here, we will use this later. This is equation 1, and let's say this is equation 2, and now we are looking for dH over dt is equal to dH over dV times dV over dt. Now dH over dt is 1000 over 1 over 4,900, dV over dt is 500, right. So 5 over 549. So this is actually, when you use your calculator, this is 0.102 centimeter per second. Okay, this is the answer for part 1. Now part B, at another instant. Now this is another instant. The rate at which h is increasing is 0.075 per second. Find the value of V at this instant. So we are looking for V here, okay, and we are given dH over dt, which is 0.075 centimeter per second, this one 0.075, right. So now dV over dt is going to be dV over dH times dH over dt. Now let's substitute the values. dV over dt we have from the previous part 500, and this one is 4 dV over dH. dV over dH is here, this one here, 24 into 25 plus h, 4, it is 25, because this is another instant, so we are not going to put the value of h here. times 0.075, right? So we will rewrite this one. This is going to be 25 plus h squared. This is 4. This will be 500 over 0.075, and this 4, it will come over here like 1 over 4. So when you calculate this, it is 25 plus h equals to this becomes 5000 square root, we are removing the square root from here, over 3, right? So from here when you calculate, h comes out to be 15.8248, right? This is value of h. Now we are looking for v. So v is equal to 4 over 3. We will again take the original equation, 25 plus h cubed minus 62,500 over 3. So when you calculate, just substitute the value of h that we got just now, 4 over 3, this is 25 plus h is 15.8248 power 3 minus 62,500 over 3. Okay, so this is, when you calculate, the volume is 69,888.51. So approximately this is 69,900 centimeter cubed when we round this to 3 significant figures. So this is our answer. Now question number 10, we have here the diagram. The diagram shows the part of the equation y equals to this, and the part of the lines x1 and y1 here, and the curve passes through points A and B. Find the exact volume generated when the shaded region is rotated through 360 about x axis. So now we are looking for the volume actually. So the volume is going to be, here we will have as it is along x axis, so this is going to be y square dx, and the limits are from 1 to here. If you see this one here, right? So this this is rotated along x axis, it is rotated along x axis, right? So this is going to become along x axis, that is dx, and the limit are going to be from 1 to 3 over 2. So this is from 1 to 3 over 2 here. Okay, so now we are going to substitute the value of this here, the y, and y we have here is 4 over 2x minus 1 squared, and the integration is 1 to 3 over 2 dx, right? So then we are going to have over here sorry, I forgot to put pi here. Pi is here, pi y squared. So pi is here, and then we can write it down as 1 to 3 over 2 y squared, sorry, that's what I was looking, y squared. So this will become 16 pi, 16 will go outside, and this 2x minus 1 power, 2 times 2 it is 4, so I can write down negative 4 when we bring it to the numerator. So then we are going to have here 16 pi. So instead of 3 over 2 I can write 1.5. So then we will have the integration of 2x minus 1 power negative 4 dx. So this is going to become 16 pi, and then we have 2x minus 1. This is negative 4 plus 1, that will be negative 3 over negative 3, then times by chain rule there will be 2 over here. So then we have the limits from 1 to 1.5. So let's see now this one again. We can write down 16 pi, and this is -3. Sorry, this 2 I forgot to put it here. It should be down as it is integration. This is going to be down here. So then we will have 16 over -3 times 2. Let's put it outside. Then we are going to put the limits inside, that is 2x minus 1 power -3. So 2 times 1.5 minus 1 power -3, then minus 2 times 1 minus 1 power -3, right? So this is going to be -8 over 3 pi, and this is going to be 3 minus 2, then 1 over 8 minus 2 minus 1 power -3. This is going to be 1 again. So then this is going to become 8 over 3 pi times -7 over 8, right? So then this 8 and 8 gets cancelled, negative becomes positive. So volume we got here 7 pi over 3, right? So this is the volume under the curve, right? Volume under the volume of this curve. Now the volume of the cylinder. If you see this part here, this part, I am going to redraw this one. So this one, when is going to be after revolution, this becomes a cylinder, this part here, this one, right? So this is going to become height, and this is the diameter, right? So diameter, as this is the 0 to 1, it's 1. So diameter is going to be 2, like 1 and down 1 here. This is going to extend down like this, right? Like cylinder like this, the one that I'm drawing here. So this is going to be radius is going to be 1, and height is from here to here, which is 3.2 minus 1. 3 over 2 minus 1, that is 1.1 minus 1, that is going to be 0.5. So h is 0.5, right? So now we are going to find out the volume of the cylinder. So volume of the cylinder is the formula we have pi r squared h. Pi and r is 1, h is 0.5. So this is pi by 2, right? So now we are going to subtract these twos. So volume of the revolution. So volume of revolution we are going to subtract that, that is 7 over 3 pi minus pi by 2. So this is, when you simplify, it comes out to be LCM is 6, 3 times 2, it is 14 pi minus 2 times 3 pi. So this is 11 pi over 6. So that's our final answer, right? Now part B, a triangle is formed from a tangent to the curve at point B. The normal to the curve B and x-axis. So there is a triangle formed. Find the area of this triangle. So we are going to find out the area. Now see, try to understand. The triangle is formed. The triangle is formed from the tangent to the curve B. Tangent to the curve B, it is here. So let me erase all this so that you can see it nicely. So we have a tangent at point B here, like this, okay? Tangent at B and normal to the curve at B. So normal to the curve at B means there is some point here on at point B that is perpendicular to this one, something like this. So I've just drawn that, but I don't know it is going to be here touching x axis or y axis, we don't know. And then there is a triangle formed like this. So this triangle, so we are looking for the area of this triangle, right? So for this we have the point of B, and we have this one here, this length. If we find out the perpendicular distance and this base, then we will be able to find out the area of the triangle. So for that we need to find out the gradient. First of all, we will find out the gradient of the tangent at this point. So gradient, we will take the curve, gradient of the curve we are going to, I am going to take y is equal to 4 into 2x minus 1 minus 2. So when you differentiate, we are going to get the gradient, that is 4 into minus 2, then 2x minus 1 power minus 3 times 2, right? So this is going to be dy over dx, that is 4 times 2, 8 times 2, 16. This is negative 16 over 2x minus 1 power 3, right? So this is the gradient. Now at point B, we are talking at point B, where the coordinates are 3 by 2 and 1. So we will substitute here to find out the gradient. So dy over dx is going to be 16 over 2 times 3 over 2 minus 1 power 3. So this is negative 16 over 3, and this is cancelled, 3 minus 1 is 2, 2 power, this is going to become 8. So we got gradient as 16 of 8, 16 over 8, that is 2, negative 2, sorry. So the gradient is, therefore the gradient is negative 2. Now the equation of tangent at B. Now equation of tangent, equation of tangent at B will be y minus y1. We have the point, we need to have the point of contact. This here we are looking for this line here. So this tangent of is intersecting at 3 and 2, y minus y1 we are going to take at B. B is 3 over 2 and 1, right? So y minus y1 over gradient is negative 2 into x minus x1, x minus 3 over 2, right? So this is going to be y equals to negative 2x plus 3 over 2 plus 1. Okay, when you open the bracket, this is going to be times 2 here. So y is negative 2x plus 3 plus 1, it is 4. So this is the equation of the tangent at B. Okay, now therefore y intercept, from here we got that y intercept is equal to 4. So let y is 0, then what will be x? Then this is going to be negative 2 plus 4. So from here we have x is equal to 2. So x intercept is 2. So it is x is 2 here. So that means this line actually is intersecting at 2. So we got this point here, it is 2 and 0, y 0 at this point, right? So we got this one. Now we will be looking for this point here, the another one. So for that, gradient of the normal, so other line is the normal. So we are going to find out now gradient of normal is going to be negative half from here, as the gradient of tangent is 2 and normal is negative 2. So then equation of normal, again we are going to use same point B, which is 3 over 2 and 1. So that is y minus 1 equals to m. M is now negative half into x minus 3 over 2, right? So just rearrange. So this is going to be negative half x plus 3 by 2, 3 by 4, it will become 4 when you multiply, plus 1. So then we have y is equal to negative half x plus, it is going to be 3 plus 4 1 5. So this comes out to be 1 by 4, right? Here is 1 by 4. Am I doing something wrong, guys? Wait. M is our negative half, equation of the normal. This is 2. Okay, yeah. Here the gradient it is coming, this is negative 2 actually. This is negative 2 here. So then this becomes positive. That's the mistake here. So then this is going to be negative. This is negative here. So then we are going to get here plus 1 by 4, right? So this is positive, right? So now when let y is equal to, when y is equal to 0 here, then x is going to become negative half. Just solve this one here. So we got negative half. So that means this line is intersecting at negative half. So this one actually, if you extend this one, so this intersecting point is negative half and 0. Now we can find out this length from here to here, right? So to find out this length, we have, see, this is 2, then this is negative half. So this actually becomes, we'll just write it down as it is. So now we are looking for the area. Area of triangle is half times base times height. So half times base, base is now 2 minus half plus 1. So this comes out to be a half, then this is 5 over 2 times 1. This is not plus, guys, sorry again. And this one is times. So times 1. So this comes out to be 5 over 4, which is our final answer for the area.